Today's video, it's all about how to revive a lithium ion battery pack. So what you see on the screen is the result of an ad that I saw online, and they said 2,000 lithium ion cells for free. So what I've got to do is go through them all, and I have gone through some of them, and I've got a fair idea what's wrong with them. So why did they throw all these battery packs out? Well, the usual reason is they don't last as long as a brand new battery pack. People get frustrated with them and throw them out. But that's what this video is about. I'll show you how to revive one. But also, I never got a charger with these battery packs, so I'll show you how I made one. A battery charger that works really well. As you can see, as I push the charge indicator light in the battery packs, some are fully charged, but most are nearly flat. But also that second row, it's very hard to see the charge indicator. So the reason why I push that battery indicator button is to show you that those battery packs are all various states of charge, but what it doesn't do is it tells you what is happening with the individual cells in those battery packs. So basically what I'm saying is you can take that charge indicator with a grain of salt, and I'll show you in a video why that is so. When charging a battery pack or individual cells, you need a multimeter to know exactly what the volts and amps are doing. But with this meter, you cannot do the two measurements at once. So what I'll have is a separate amp meter to measure the amps. This is an infrared handheld temperature measuring device, and it is vital to use one when you're charging up a battery pack or individual cells for the first time. What I do is you measure each individual cell continuously every 10 seconds, and when you see one is getting really hot, you have to back off or switch off, because if you don't, you may have a battery fire, and it's something which you don't want to have at all. To charge up a lithium ion battery pack or individual cells, you need a variable voltage power supply. And the one shown in the video here is one I made from a MIG/stick welder, and it works well. Here is a close-up of the power supply, and there's the knob where I actually adjust the voltage. It's connected to the potentiometer, and that's the positive output cable, and it's connected to the jumper leads. That's positive, and then you'll see the negative that's connected to the amp meter. So you've got an amp meter reading, and finally up top is the control transistor and the back side of the potentiometer and the resistors I use to control it. This battery pack has 10 cells in it, and each cell is rated for 3 amp hour, but on the label it says 6 amp hour. So how they do that is they put 5 cells in series, and then another 5 cells in series, and then they connect them in parallel, and then you've got 6 amp hour. So when you've got 5 cells in series, it gives you 20 volt rating. As you can see, there's only one light on the battery charge indicator, so now I'll measure the battery pack voltage. The battery pack voltage is 17.24 volts, but I don't know what the individual cell voltages are, So I'll have to dismantle the battery pack to find out. Did you see how low the first two cells were in parallel? It was only 2.8 volts. So this is why I recommend that you dismantle a battery pack to see exactly what every cell voltage is. So what will happen when you connect this battery pack to the proper charger? Most likely it will reject it because the two cells have a very low voltage. But if the battery charger doesn't reject it, it will charge the higher voltage cells, but the ones with the lower voltage, it won't charge that to full voltage, and therefore the battery pack will not last as long. I have connected up my variable voltage power supply to the two cells of which are the lowest voltage. But there's a very important point that I must emphasize. This power supply is not automatic, so you must continually watch what the voltage, amps and temperature of the cells are doing. You cannot walk away from this. If you do, it will be a disaster. For the first time charging these two cells in parallel, I will put on 0.5 amps. It's not much, to be very gentle to it, and we'll leave it run for 2 hours and we'll see what happens. The 2-hour charging time has been completed and we've gone from 2.86 to 3.78. So it's a fair increase. But the interesting thing, what happened is at 1 hour, it went from 2.86 to 3.67. And then another hour later, it went to 3.78. So you only got an increase of about 0.1 of a volt. So what's happening here? This is what's happened to me so many times with these lithium ion cells. I call it the memory effect. So if you left that charged for another 2 hours, you probably would only get to about 3.9 volts if you're lucky. So what you've got to do, you've got to discharge the battery, then charge it up again, and then discharge it, and then charge it up again, and you'll notice the increase the voltage, but also it'll shorten the charging time. To discharge these two cells in parallel, I will be using a halogen downlight. It's 12 volts at 50 watt. Now running it at 3.7, it's going to be less than 8 watts. So I'll be draining it until it goes down to 3.2 volts and then repeat the process. Watch when I switch off the power supply, you'll see the cell voltage drop down less than 0.1 of a volt. So that means that those cells are going to be okay. Discharging the two lithium cells in parallel, it took 45 minutes, which is a good sign that those cells are reasonably good cells. But also, as you can see, it takes quite a while to discharge the cells and to recharge them again. It's not a quick process. Discharging those two lithium cells in parallel made a big difference to the second charging cycle. So what we started with was 3.26 volts, and in an hour it was 3.8, and then the second hour it was 4.01. So now I know that that procedure works. I will do the same for the remaining cells, and then we'll do the big test when all the cells are all charged, put a suitable load on it, and we'll see how long the battery pack lasts. The suitable load I will be using, it is a cordless drill. So there I'm measuring the battery voltage before the test. It's 20.31. So what the deal is this time round, I will connect the battery pack up to the cordless drill, and then what I'll do is I'll run it for exactly 1 hour and then note the voltage, exactly what the voltage is after an hour, and then I'll recharge the battery up again and then repeat the same experiment, and I'll be able to see if the voltage actually increases or decreases, or if it has improved the battery pack at all. This is the voltage after 1 hour. It is 18.9 volts. So this is the voltage I've got to beat in the next run. When the battery is not under load, as you'll see, the voltage will increase. This is the second load test, and the starting voltage is 20.31. The battery pack voltage is slightly down from the last load test, so that means there is no more discharge charge cycles needed. It can only revive the battery so much. So this is another important test for a battery pack, is to charge it up to fully charged voltage and then measure the voltage, write it down, and then measure it every 7 days for about a month and see if the battery voltage is dropping down. Because if it is dropping a lot, you're losing capacity on that battery. Check out the total voltage of these battery packs. In series, there's 8 of them, and each one is well over 28 volts. So I use it to power up this power saw, and we're cutting some red gum, which is the toughest wood in Australia to cut. It'll make this power saw really work. I was wondering about how far the battery voltage would drop when the power saw was under load, and it was 20 volts. So I might have to add another battery pack on there to compensate for that drop. This is the second experiment. I put all the battery packs in parallel so I can use it as a stick welder, but unfortunately it was a failure on 2 accounts. So I had a lot of trouble trying to maintain the arc, which the battery pack wasn't giving enough amps. And the second part of the failure was my brand new meter, which I was using to measure the amps. What happened with it? It has a very low sampling rate, and what happens when you arc weld, the amps tend to go up and down a lot, and it gives a very flickering reading, and it's very hard to figure out exactly what the amps are. But if you look closely, you'll see it's roughly between 40 and 60 amps. What I'll do is I'll reconnect the amp meter to one battery pack, and I'll see exactly how many amps are coming out, but also see if it's easier to read. This time the amp meter has been set to 0 to 40 amps, and see if I can get a stable reading. Yeah, have a look at that. It's not very good. I thought it might improve it because the last reading was 0 to 400 amps. Yep, not improving. So I'll have to end this video with 2 failures, which shows you can't win them all.